and welcome to Tech and Test with me, Peter Johnson. Today on the show, we have Iosif Itkin. Iosif, thank you for coming on Tech and Test. Really appreciate it. Today, we're going to be talking about testing and AI testing and using AI in testing, all the AI and testing things and combinations. Iosif, if anyone doesn't know you, they should know you. How do you want to introduce yourself?
Hello, Peter. Hello, everyone. Thanks a lot for the invitation. It's truly a pleasure to be here. I'm co-CEO and co-founder of ExactPro. We are a small niche software testing business. We are employing several hundred specialists, and we are mostly focused on financial market infrastructures such as exchanges, clearinghouses. We do a lot of software testing, and we are also looking to finding better tools and methods of testing software.
Awesome. Yeah. So today on Tech and Test, I've given you a whole bunch of questions, right? Around what I think are important, right? Some of them are like around testing oracles. Some of them are more to do with like data and like, is data like a primary source of failure? And also we're looking at like maybe biases in testing and just kind of all those things which AI brings to the table. But the key thing I think to start off is like, what would you think is like one of the main key differences between like AI testing and what some people may call traditional testing?
Great question. I was thinking about it a lot and also prepared a number of slides that I hope we can now
Okay,
walk through.
awesome.
Why is AI testing different from traditional testing?
Yeah.
The term traditional testing, uh, different people refer to different things, but it would be fair to say that some of software testing fundamentals that are applicable to testing AI systems and non-deterministic systems were known for quite some time. So there were things that were established like 2 decades ago, 3 decades ago,
Mm.
etc. And some people think that software testing for deterministic systems allows to test everything, and non-deterministic systems are different from that because we are not able to test everything. But in reality, it is well established that it is exhaustive testing is impossible. Software testing can only show the presence of defects, not their absence. So if we think about this as traditional testing, then this has a very good tradition of exploring complex systems. If instead we are looking at a more straw man definitions of traditional testing, like focusing only on predicted outcomes, then of course it is not something that is appropriate for the modern generation of systems, and it is also not applicable to any new systems. And it was not applicable for any complex system previously. So testing is not about proven correctness. So what we have on the screen is in fact a joke. So it says testing is a process of establishing confidence that a program does what it's supposed
Yeah.
to do. It is from Glenford Myers' book that was
Classic.
written in 1979. But in reality, so the first phrase after that, it says, these definitions are incorrect.
Mm.
They describe almost the opposite of what testing should be viewed as.
Hmm.
So testing is not establishing confidence. Testing is not aligned to prove correctness of the software. The only thing that testing can deliver is detecting and describing defects. And this was applicable previously. It is even more applicable now in the world of AI testing. And today we will also look at traditional testing tradition and at the some documents that were produced like 30 years ago and how they are relevant for exploring non-deterministic systems.
Interesting. Yeah.
Yes. So personally, I think that software testing is about finding and describing bugs. Testing shows the presence, not the absence of defects, and exhaustive testing is not possible. So testing cannot provide confidence. It cannot provide information that something works correctly. It only can describe what is wrong. And the definition of bug in my personal practice, I tried to use the definition from rapid software testing,
Hmm.
where a bug is linked to a threat to value.
Mm.
Anything that is anything that can decrease or threaten the value of software to someone whose opinion matters should be considered uh, a defect. And this sometimes cause controversy. People think that software testing can provide other information, for example, information about risks, etc. But what is risk? Risk is the probability that something bad can happen.
Right.
And if there is probability in the software that something bad will happen,
Mm.
it is certainly a defect. Another example, people say, but if it is just an usability issue, it is not a defect. It's not a functional defect. But usability is ability to use the software by people who matter. And if there is something in your software that makes it harder for them, it is certainly a defect. And by focusing on things that are important for people, by focusing on detecting and describing defects, we as software testers perform our information service and help stakeholders to better evaluate the software that they're trying to build. Yes. There is a treasure chest of materials available online. So
Oh, yeah.
often, when you look, have you encountered black box software testing?
Yes. Yeah. These are some really good materials. I've definitely encountered the black box software one. Um,
Yes, so it is from their website. There are so many things that describe test oracles, uh, a separate section describe high volume test automation, and it was created like 20 years ago.
mm,
But if one start reading about what Kemp suggested at that time, it is difficult not to see that uh, this is testing using AI, using computer assisted methods, but just 20 years before
mm,
everyone start thinking about using AI to support testing. So there are many good materials. There are many bad materials. I would say one of the indication of a bad material is when it insists that previously no one was thinking about non-deterministic systems or probabilistic
mm.
systems. Say in our own work, when we work with low latency exchange infrastructure,
Right.
most of the systems used by exchanges, they are distributed very low latency. And it means for any distributed system, you are not able to guarantee uh, for two nearby messages which one of them gets earlier into the system unless they're sequentially ordered somewhere. But in a distributed system, due to the presence of many components, you can't necessarily say which one will get there faster. So
Right.
non-determinism was present in many distributed systems long before AI became popular. Another example would be that people try to manipulate opening prices in the market. Say something happened during the weekend, and everyone is not aware what would be a good opening price on Monday. So people are submitting orders into the auction in exchange, and everyone is trying to see what others are thinking. And if they are unhappy, they're trying to cancel their orders at the very last moment. So this happened, for example, during Facebook IPO in 2012, where people started canceling their orders. That's why many exchanges try to have a random uncrossing time. So you can't say when the auction will happen, and it prevents people from manipulating the market. But what it means from software testing perspective is that even the simplest process of opening the market is already non-deterministic. There is probability that it will open from, say, 8:00 to 8:30 seconds. And under heavy load, most of the processes there are non-deterministic. That's why people who work with non-deterministic systems, distributed systems, have to develop methods that are applicable to work in such environments. And the next one, we go to the main question of non-deterministic systems is, of course, test oracle problem. It would be fair to say that in the current software testing education, it is not sufficiently covered. So it is perfectly covered in materials that were published 20, 30 years ago. But if we look at the latest CTFL syllabus by STQB, there is not a single mention of the word test oracle.
Right.
And it is, of course, not okay. So in CTAI syllabus, it is present. In
Right.
foundation level, it is absent.
Mm.
So that's why there are variety of misconceptions of what a test oracle can be. And often people think that test oracle is something that will show if a test pass or fail. And this is it is a bit simplification that is not allowing us to use it for most of the systems, especially to the new systems like AI enabled systems, because it is oversimplification. And what
Yeah.
is funny is that people were aware that it is oversimplification long before AI appeared. So there are extremely good materials available absolutely for free in the public domain by Duke Hoffman about test oracles. They are referred from black box software testing uh, materials, and anyone can just go and Google, and they will find another treasure chest of materials that explain both taxonomy of test oracles and also give a more appropriate model of the systems under the test. So this is a very simple illustration of why things are not as simple. And so say during job interviews, sometimes, well, it's probably already a meme, but at some point people were asking how to check which switch leads
Mm.
to which light bulb. And so you need to use your imagination to figure out that it is possible to switch on one of the bulbs, wait until it becomes warm, then switch it off and switch another one. What it illustrates is that even in some extremely simple interaction with the test systems, we are able to change their state in ways that we do not necessarily immediately see. So we have free bits, but it appears that in any reality system, these are not just free bits. And Doug Hoffman, so in 1998, so it is what it is. It is 28 years ago, put a more elaborate model of testing where we are not just having inputs, outputs, and the system under the test, but there are also many other things that contribute. And with things like preconditions, environment inputs, environment outputs, post-condition state. So it is not just something that we immediately see, but also many other things
Right.
that change internally. And that's why many methods that just focus on deterministic input, deterministic output, usually do not take it into account. But say if we have very simple scenarios, we are adding a record and then we are marking it as closed. And we think that we are in the same state as before, but we are not because we have identifiers changed, we have more data in the system, etc. And amazing thing is he put implications of expanded model. So once again, it is more than 25 years ago. And the implications of his model are we don't control all inputs. We don't verify everything. Multiple domains are involved. And the test exercise is usually the easiest part. And we can't verify everything and we don't know all the factors. So this is something that he described 25 years ago. And now when we think about AI systems, everything is relevant. So we don't control all the inputs.
Yeah. Wow.
Don't verify everything. And that's why it is not something that was invented when ChatGPT came into being, or not when there was a rapid progress in deep neural networks.
Right.
It is something that people who were thinking seriously about software testing were aware long before. And that's why if somebody studies software testing seriously, looks at the good materials, and there is such a huge volume of good materials available online, then they will be prepared to the situation when you can't control everything and you have to deal with it. And it is a part of good traditional testing.
Very good point. And I think when I was talking with James Buck on this podcast, something we discussed was the conceptual idea that people falsify testing, right? And they come up with their own ideology of what testing is within an organization because it suits certain metrics and it suits certain patterns that you can report on, right? But if we go back to this definition of testing and this definition, this model, we can just see how complex testing is and how I would argue some of the testing people do isn't really testing. If you think about what are you actually controlling and what are you actually observing?
Sure. Yes. And so one example would be that if you put as the objectives for testing that it should be fully automated, that it should be very fast, very cheap, that it should never report a false defects, that there should not be any flaky tests, and many other things, you can satisfy all these criteria by not doing any testing at all. So the only way to have real testing is to focus on identifying defects. If you have any
Yeah.
other objective, like have 100% automation, not doing anything is a fully automated process, because automation is the absence of a human in a process or procedure. And if you are not doing anything, a human is not required. So 100% automation is easily achievable without involving human and without doing anything. Yes. So the second very important contribution by Dr. Hoffman was description of test oracles, types of test oracles, test oracle taxonomy. And now we can see that many of the things people were thinking about then, they are very relevant to the current age of AI testing. So he put a number of test oracle types, and I will very briefly walk through some of them. Uh, but before that is the definition of test oracle. So test oracle is not something that says whether test pass or fail. And people were aware of it for decades. So you can frequently encounter statements in LinkedIn in articles that previously test oracle was pass or fail, and now with the introduction of probabilistic, non-deterministic AI systems, we need to switch our thinking. But 20, 30 years ago, people were already aware
Yeah.
that there is no such thing as ideal test oracle. And test oracle should be better treated not as something that says pass or fail, but something that attracts attention. So it is something that
Mm.
gives indication that
Mm.
something can be an incorrect behavior rather than a definite
Interesting.
response of pass fail. So test oracle is more like an alert threshold
Yes.
to
Yeah.
call a human rather than uh, a definite pass fail mechanism.
So a good example of this would be like a Prometheus dashboard or some alert that goes off, triggering someone to take a look at the data, right? Some metric has gone beyond the threshold that's been set.
Exactly. And even so, Prometheus, in our own world, we use it very often with Grafana during non-functional testing, during
Right.
performance testing. And if we look at performance testing, most of the questions that
Yeah.
you ask in performance testing are not uh, pass or fail, but more like distributions and alerts. So you can have you can have SLAs that something will not go outside particular latency threshold. But most of the time, it is not a fixed binary yes, no, but it is more like latency distribution. So we expect there is some tail. This tail can be caused by microbursts because, say, in stock exchange, people are not submitting their orders at even period for exchange
Sure.
to be comfortable. Something happens and all robots, all humans simultaneously start pushing with all
Yeah.
their might immediately. And of course, then there is some latency tail. So when you do performance testing, you look more at probability distributions rather than at fixed values.
Yeah.
And and alerts in systems like Grafana parameters is a very close to the things like fraud detection systems. So when
Mm.
uh, fraud detection is a good example where you have to have a certain threshold for uh, flagging transactions that are fraudulent, that have high probability of being fraudulent, but you are not able to uh, decrease the threshold to a level that will overwhelm humans and analysts with. So if our system will uh, label every transaction as fraudulent,
Yeah.
humans will not be able to do anything with that. And the same goes to a degree with the software testing. If we have rule-based or if we have AI-enabled test procedure that interprets the output of test execution, we would like it to balance between highlighting things that deserve our attention from the things that probably do not deserve our attention. And of course, there are always mistakes. So it is possible that if we have some AI-enabled procedure, that it will skip something that is important and will not alert a human. Or the opposite side is that humans will be overwhelmed
Yeah.
with indication. So currently in cybersecurity domain, people complain that there are too many false positive reports so everyone is now attacker takes code waiting for me for system goes and receives a number, here's bug, and they go and submit it to a variety of open source projects as a bug bounty. So some companies now even cancel bug bounties because
Mm.
the, the threshold set for identifying problems is not
High
sufficient.
enough. Yeah.
Yes. So, but once again, this definition of uh, test oracle, it is present in Kemp-Connor's materials from 2010, from in materials from Douglas Hoffman from 1998, etc. So, humanity were we were thinking about it and we were preparing for the world where we will not immediately be able to say that something is pass or fail. So there is no such thing as complete oracle, and it most of the time it would be an illiterate position to expect that it is possible to have something that will be an authoritative mechanism that will say that this program is passed or failed. So everything is probabilistic. And we can argue what is the reliability of these methods, but all test oracle are stochastic. So the fact that we have non-deterministic things based on the current technology, it is something that that is expected. So we have to deal with it, but we can take some comfort in the notion that there is no such thing as a complete oracle that will definitely say this is false, this pass, this fail. So it is unicorn. Everything that we can have is stochastic, heuristic based partial oracles. So they can verify some aspects of the output. All oracles are partial oracles and they exist. So partial oracles exist. And of course, they can miss systematic errors, they can miss obvious errors, but it is the consequence of the fact that they are partial oracle. On the bright side, they exist, in contrast to complete oracles that do not exist.
Yeah. Is that kind of, I guess, in practical terms, right? This is some kind of alert or something. Someone has defined what that threshold is, but they may have got that threshold wrong, but it may get some issues some of the time, which is why it's a partial oracle potentially, because the threshold may not be updated correctly sometimes, and then you could miss some issues still, right? Using that that Prometheus metric example. So
Yes, and it is exactly like in machine learning, you can have false positives, you can have false negatives. The
yeah,
same, you can think of any test interpretation procedure as a classifier. It
yeah,
can highlight correct things as correct things. It can highlight bugs as bugs. It can highlight bugs as not bugs, etc. But what I think is important for people who are trying to use machine learning in software testing. It is important to understand that the classifiers should be built around detecting defects. So true positive is when there is a defect and you detect it. It is difficult to say that it is positive. What is positive about having
Yeah.
a defect? But
Yeah.
it is not so it is not possible to build a classifier that will say uh, there are no defects
Mm.
and it will be a true statement because there is no software
Mm.
without defect. And if we have a classifier that says there is no defects here, we already know that it
Is lying already.
is lying already. Um, fun test oracle in Doc Hoffman's classification is human oracle is when uh, you specify when human decide if something is uh, good or bad. And a very nice example that I frequently referred to is from Supreme Court decision on how to interpret materials that follow the definition of hardcore pornography. So the justice, sorry, not the judge, justice stated that I know it when I see it. So I will not put it in writing, but I
Right.
know it when I see it. And so once again, it is from like 50 years ago, but the idea is that it is when we think about spec driven development, or the ideas that we can put in human language something. So currently the idea is we can just describe in human language what we need, and then code assistants will go and write us the code. So the problems start even before we go into code with the requirement specification. So first of all, human language is ambiguous,
Right. Yeah.
and there are good reasons to have clear terms, to clear defined terms. Curtis said that attributed that definition of terms is the beginning of wisdom. But there are also cases where we specifically do not want to be precise with the language. Somebody can say why we can be not precise with the language. So it will always be better to be precise, but in reality, it's not. And apart from pure poetic reasons, so we would like to use the same word to mean several different things. There are real reasons. For example, if you put into the law something that can be interpreted several different ways, you make it harder for the criminals to decide if what they will do will violate the law or will not
Mm.
violate the law. So uh, one can say, no, we need to put it precisely. But everyone who have ever distributed budget in a large organization knows that budget it is not a limitation that people will not spend more. Budget is exactly so whatever figure you put there, it will be spent down to zero or
Yeah.
very close to zero. So if you do budget in every organization by uh, putting some statements like spend reasonably,
Mm.
you uh, somehow force people to use more judgment.
Mm.
And it is applicable now when we think that we will be able to put text description and then AI will go and code everything for us. There is a nice Oracle strategy that is called no Oracle strategy. It exists, and in fact, it is not such a bad thing. The idea is that when you are not able to
Mhm.
check functionality, but at least you can see some spectacular failures. And in fact, it is not such a bad thing. So I can give a number of examples. So if you have a complex playwright script, it might be difficult to say when something is right or something is wrong. But it can be very easy to see that there are HTTP 500 or that there are errors in JavaScript console. So it is possible to have a separate fixture that will check that there are errors in HTTP 500 console. Just in JavaScript console, that there are errors. So you might not necessarily understand the business process that is present on the website, but you can immediately see that there are exceptions in logs, there are errors in console, or there are invalid responses. So it is, while it is called no Oracle, it is still an Oracle, but for spectacular events. And it is relevant to the current age of testing. So most of the time, we might not necessarily be able to interpret the output that goes out from the chatbot, but at least we can have a regex for particular bad words. So like code, it appeared that in the
in
own
the
source
source
code,
code.
they use regex quite a lot as efficient way of
Yeah.
exploring what is there. No Oracle test strategy was also known for quite some time. Um, Another real example would be that the system is still operational. So we still receive something. If we still receive something in Prometheus, then at least we can see that it is alive. So it is possible to generate a lot of random, unusual inputs. Some people call it fuzzing, but yes. So, and once again, it was invented not over the last few years to test specifically chatbots. It was something that was always there. Not always, but for
Yeah.
several decades. Now, interesting thing is handcrafted Oracle strategy. This is actually what everyone expects. Not sorry, it is a straw man. What many people think is test Oracle. So you have this input, this output, a deterministic one, and they say this is my test Oracle. But in reality, it is just a tiny part of what would be a good test Oracle for the systems. Yes, so here's definition of what what is relevant for test oracles, and it is an interesting thing that uh, when we have what I would say when we have complex system, and if every call to this system results in money spending, it might be a good idea to clearly separate test execution from outputs evaluation. What it allows you to do is you run something once and you pay for it because you have to perform some API calls. But then once it is completed, you have a data set and you can run variety of interpretation scripts or checks against this data without repeating the test. So when execution is split from interpretation, it is possible to have one execution for many interpretations. And also, uh, when we use complex models to evaluate something, the probability that there are problems in our models is very high. So and when you have assertions that only work during real time, it means that to repeat the test with these assertions, you need to repeat the test. If you have a test that captures the data and stores it somewhere, it is possible to run assertions against the captured data. And then if we see, oh, we were expecting something wrong, we can modify our expectations and rerun them. Traffic is real. Our interpretation is like feelings. So we have facts, real data, and we have feelings, what we feel about this data. By enabling running interpretation several times, we save time and money on execution and on software testing. Well, independent implementation, here, of course, there are difficult things for the current foundation models. So previously it was possible to have something model and then use this model as the reference point. So you have an independent implementation, and then you submit the same input into the system under the test and into your model. But say if the current model is a foundation model that was trained for 10, I'm not sure, 10 billions dollars, it is not something that you can go and recreate on your several GPUs that you have for Bitcoin mining, and now you decided to repurpose it for model evaluation. Many people try to do something like that, so they are creating alternative implementation to evaluate it. But of course, it is not something easy. But it is possible to limit to input ranges or to limit on some specific subsets. So James Bach published an interesting article when he was trying to get apple pie recipe from several different LLMs. And his simplified independent model was that this is a list of ingredients that I'm trying to check the outputs against. So maybe there are cases where it is possible to use simpler implementation strategy to evaluate something complex. And the one that is very efficient for old systems, for deterministic, is regression test oracle.
Oh, this is a classic one, right?
Yes, exactly. So what is regression test oracle? So once your unattended scripts, automated scripts executed and have not reported anything against some data set, they are no longer tests, they are now automatic checks.
Right.
And to a degree, regression testing is testing where your previous version is the model of the new system. So all testing is model-based testing, but regression testing is specific model-based testing where the previous version is the model of a new system. And in reality, it is true that having deterministic behavior allows to greatly decrease the cost of checking something. So if we can repeat something twice, then to spot the small differences is very, very easy. And for most deterministic systems, it works. What to do if we have non-deterministic, if we have machine learning system as a part, or if we have a foundation model as a part of our overall environment, we just need to accept that there is a part of our system that we are not able to test this way. So we do have something that works perfectly in deterministic way for repeatable things, but we are not able to use it. What's important is often we are not able to use it for a subset of system. For example, we might have an algo trading system that is connected to several stock exchanges, and we are not able to predict how the market will respond to any of our orders. So there are competing robots, there are other people. So you send an order, you get not random, but close to random response. When you send an order into the market, you have no guarantee whether it will be filled or it will not be filled. So, and that's why it is not possible to test one thin layer that is connected to the market in
Right.
deterministic way. You have to assume that this part of your system is non-deterministic, and you have to develop methods to explore it in assumption that it is non-deterministic. But the rest of your infrastructure, it should be deterministic. So by clearly outlining domains within larger system, so this is where I can have repeatable things, and this is where I'm not able to have repeatable things. It is very important to do it now. So say if we have a block that uses external LLM API, we've collected 1,000 responses of things like that. We know that when we will repeat our requests, we will have different uh, behavior. But at least we can go and check that for the same responses, the rest of our infrastructure remains the same.
Yeah.
Even in the current world of unpredictable software, we do have some things related to regression. So this was probably the largest block related to test oracles. So how do we know what we know? How we can say whether we need to call human or whether we can ignore the data? Next one was why in AI-based systems, why is data the primary source of failure? And in our book, we do have a diagram taken from a source of the effort related to building machine learning systems. It is clear that most of it is data related.
Interesting. So,
And yes.
I mean, traditionally, if we think of like the skills normal QAs and SDETs or someone in the testing space has, very rare they tend to have a lot of data analysis skills, right? Or they've not often been involved in the training of these models sometimes, right? They're usually separate teams of people that do this.
Good point. Domain. Personally, I've used to work a lot with exchanges and clearinghouses, and often they are produced by companies or bank system. So they are produced to be used in many different environments. And a software development vendor has to accommodate to regulatory, client, instrument, and lots of other permutations. So when you look at this system, it already has a huge volume of switches and toggles like this, and that. There's a meme that shows this is how Google screen looks, and there's a single input bar. This is how Apple looks. There is a single button. And this is how your application looks. And then there is a form with 40, 50 different controls. But any enterprise system already had quite a lot of data and configurations. So I met systems where the volume of toggles or parameters can be measured in thousands. So there are thousands of parameters that determine the system's behavior. But with machine learning, it is like one step further. So there is a small amount of code, and even if it is most of the time, it is the code itself is not is not very complex. So there are algorithms, machine learning algorithms, but they are limited. And then there is the volume of data is several times higher. So what it means that the time and space for making an error related to the code is smaller in comparison to an endless ocean of possibilities to make mistakes with the data. So to introduce bias, to introduce errors, to have poor data quality, to have duplicates, etc. So if we have to write small amount of code, we still make errors there, but they are constrained to a small volume of code. And then we have data that is constantly changing. And if in our systems we have this ocean of data that's substantially larger than the source code, it is expected that errors will be, even if they are as frequent in data as in code, just due to the volume of data, most of our problems will be data related. So it is a very simple explanation, um, why uh, why problems happen in data. An
Yeah.
interesting thing is that Cam Kanner, when he came out with the term exploratory testing,
Mm.
he was inspired by a process called exploratory data analysis. So he was thinking, oh, there are people who in modeling, in other industries, that they are looking at data sets and trying to explore and find something that is wrong. So he was inspired by this term, exploratory data analysis, and he introduced the term exploratory testing. And now, when most of our software is data, then it's like making a full circle. Now, exploratory testing is exploratory data analysis.
Yeah, good point. Yeah, and it's interesting because um, with the kind of data problems, right? They need more. You can't just system test it, right? You need to have different stages of testing where you verify the model, you verify the data. This testing has to happen all through the process, right? Because it's very difficult to find problems in a data set using an end-to-end system, right? You can see some biases maybe, or you can see some particular things, but it's a lot easier to try and test that at the data cleaning phase, for example, or, data processing phase rather than in the end-to-end system where you're trying to write a playwright test that's going to analyze the response from the LLM, for example. So yeah, it just shows that we also have to be involved much more or testing has to be involved much more in all of the process, right? And if that's not happening, it becomes even more important given data-driven systems.
Sure. Yes, and of course that the next question was on bias,
Yep.
fairness, in failure mode. Why all these things happen is because data is now a larger set of what we have in comparison to the code. We had very good discussion, so it is a separate well, maybe not 2 hours, an hour and a half chat with
Nice.
Olivier Denou on AI biases unleashed. So I highly recommend. When we looked at several aspects related to biases in data. But one thing that I would like specifically highlight is so our book is on ISTQB AI testing syllabus. But before that, there was its predecessor called A4Q, Alliance for Quality uh, uh, syllabus. So it is like not a grandpa, well, probably grandpa
Yeah.
of the current syllabus. And
Okay.
to a degree, it is better. So there are some things that were there that are better, and somehow they were not getting into ISTQB syllabus. And
Mm.
one of the biggest omission is the concept of bias variance trade-off. So somehow it never managed to get into the syllabus. And the fact is that there is a trade-off, and there is not just a single trade-off, but there are many trade-offs if you try to make the system more fair, it becomes less accurate. If you're trying to
Yeah.
make it more fair by race, you get it less fair by gender, etc.
Mm.
And one thing that is very important, so I was thinking about this question. So, what is the most important consideration in this for software testers? And I believe that the most important consideration in dealing with such systems with anything in software testing is that there are no solutions, there are only trade-offs. So any strategy that you have is not a solution, it is always a trade-off. So when you choose one road, you immediately not able to choose another road. And this week, in fact, it appeared that AI index report by Stanford, they published it every year. And it was published this week. So on 13th,
Perfect.
yeah, it is like 300 or 400 pages, highly recommended. And there is a section that is called trade-offs across responsible AI dimensions. And it is, I believe, very good section to read for any software tester, that it describes that when you try to improve something on one dimension, you make it worse on other dimensions. And we as software testers need to explore it. And so we need to understand that it is not a problem that is easy to solve. That and yeah, this is what I think is important, and it is true not just for bias. It is true for any software testing endeavor. The thing like what we discussed with the thresholds. So if we will make classifier more chatty, then the probability that we will miss a
Yeah.
present ticker is lower. But on the other hand, it is possible to make a classifier as chatty that people will at some point start ignoring. So, oh, this is
Yeah.
once again, and like and these things happen. These things happen in real systems, and people die because somebody assumes that these indicators they are always blinking, and then there is a single case where they are blinking,
Yeah.
and it appeared to be the case.
Yeah, it's almost like, someone gets into a car and the warning light's on, and they've got so used to the warning light being on all the time that one day a component fails in the car and it's like the car stops working. But it's the same thing here, right? It's if you're creating too much noise, it becomes normalized that people just accept it, and
Yes,
it's no
and
longer.
if you are not creating enough noise, then it is possible that something very important will not be uh, reported,
Mm,
and people will not be aware that there is a problem. So, and one thing that was removed from ISTQB CTFL when they migrated from version 3.1 to version 4, they removed the whole section on test strategy because it was considered that foundation level testers, they're probably too young to think about strategy.
interesting.
Yeah, I disagree. I
Yeah.
wrote that I disagree, but the idea is that what is strategy? Strategy is selecting things not to do. It is choosing not to do something. If
Exactly.
you choose to do everything,
It's not
it
a
is not
strategy.
it's not a strategy. Yes, a strategy is not doing something.
Yeah.
Yes, and
And being intentional about it, right? So it's not just that we ran out of time. It's like, no, we're not targeting this because it's not a priority.
yes, exactly. So, and I believe it should be a core part of every software tester. education. So if somebody thinks that we can test everything or something like that, it is just a sign of, well, like unicorns and rainbows. It is not something that exists in the
Yeah.
real world. And in the real world, every time we do something, we are not doing something else.
Yeah.
It is that's why there is the whole debate on QA versus software Testing. So when a software tester is uh, is writing requirements or writing code, they are no longer software tester. Why? Because at this very point in time, when they improve the code or when they improve requirements, they are not doing software testing. So and good requirements and good code are very good things, but in the real world, we are not able. So to choose between good thing and a bad thing is not a choice. It is easy. So do good,
Yeah.
do not do bad. But most of the time, we are not facing, when we do software testing, we are not facing two one good and one bad. Most of the time we face two good things. Well, most of the time we face two bad things, and we have to choose which one of them is a lesser evil. Yes, so highly recommend this report. There are many interesting things there, and we probably now can go into testing with the AI.
Yeah. So this is obviously like a very big topic, right? And it's becoming very like everyone's using on my LinkedIn feed, and I'm seeing it in the industry. Like everyone's trying to build an AI tool or RAG pipeline or a or just use Claude Code, right? So I'm interested to hear your take on how AI can help us test. Like instead of testing AI, what tools can we use, and how can it actually help us?
Sure. So the first thing is, of course, so to use AI in testing, it is important to understand both what is AI and what is testing. And in fact, it is not the term AI is not something that is easily defined. So
Right.
this one that I like. So James Bach says that AI is automated irresponsibility,
Mm,
and his claim is that AI will never be reliable or responsible. Here, fact would be it would not be fair to say that reliability of the systems is not increasing. So they can be still unreliable, but it looks like there is technical path to make them reliable or to at least to substantially increase their reliability. On the other hand, there is no such thing as responsible AI. So AI cannot be responsible. It has no fear. So why people are responsible? Because they fear something.
right.
And AI has no fear, so it can be made responsible. And at the moment, we do not see any technical solution for making it responsible. That's why
Yeah.
in the report, in Stanford report, they do use term responsible AI, but more accurate term would be, of course, responsible use of AI, because humans can they
Sure.
have pity, remorse, fear. AI has nothing of that, so it can't be responsible. A popular view now is that AI is only uh, foundational models or LLMs.
Mm,
There is a concept that as soon as something becomes reliable, it is no longer AI. So it is called AI effect. So say if we ask like 40 years ago, if computer software will be able to win a chess game, is it AI? Everyone will say, of course, it is. Chess is a very intelligent game. It requires thinking. It is not possible to brute force through all combinations. So if we ever create a chess program, it will be AI. As soon as this milestone is achieved, and we now have software that is reliably able to win against any human, it is no longer AI. So AI is something that works unreliably. So welcome to use it in software testing. That's why in AI testing strategies in documents in test plans, it is a good idea to specify what we mean, whether we mean
Sure.
machine learning, whether we mean deep learning, large language model, or we are talking about a very narrow, well, it is narrow, but it is probably the one that currently gets most of attention. So large foundation model, Claude, Codex, Opus, Grok, etc.
Sure.
And we had over the last 2 years, we have both internally and externally, we have constant debates on whether we use AI or we do not use AI. So if we use decision tree, is it we are using AI for testing or we are not using AI for testing? So it is a difficult question.
And it's also AI, if we're saying it's an AI system, it could be an AI system, but maybe from the 80s, right? What we considered AI in the 80s, right?
Yes. Decision tree is, of course, an AI system from the 80s.
Yeah.
One can argue that any linter, any syntax analysis would be considered to be an AI system. But now we are saying that Shazam, because it is not using certain methods of machine learning, but use some search, is not an AI system. But
Right.
if we ask like 20 years ago, if uh, I will switch on a song and software will tell me the name of the song, is it AI or not AI? We're going to say, yes, of course it is AI. But now, no, it is just some search procedure.
Semantic search.
Yes, exactly. In fact, the first version of European Union AI Act, uh, there was a different definition of what is AI, and it contained a list of systems and list of technologies. And most of these systems would have fallen under this definition. Like it says, if there is a search, it is AI system. If there is
Wow.
optimization, it is AI system. But now they changed it to now European Commission in the final version of EU Act, there is a more appropriate definition, but still, so no one knows what is AI. And when we try to communicate that as the software testers, we are using AI, it is a good
Sure.
idea to now on the question of reliability. So as I mentioned, AI, we do not have a technical path right now to make it responsible. Can we make it reliable? So this is one of the highlights. I believe it is present in most of the press releases about Stanford AI index report. So the idea is following. They're saying that AI models can repeatably win math Olympics, and they can respond to most of the tests very well, but they are not able to guess the time on the clock. And here is the special benchmark that is called clock bench accuracy. We can see that all frontier models are way below of what somebody can expect. So it is one of the main highlights. And then
Wow.
if somebody will say, can we use AI for testing? Okay, so you are not able to use any frontier model to test your clock or things like that. And what can be simpler than a clock? So on a question of reliability, it's an interesting thing. But we do know that there are no complete oracles. All of them are stochastic. And
Sure.
it is possible to use things that are not 100% reliable, but one needs to be aware. So there are videos on YouTube where, people harass Claude or ChatGPT about how many R's in strawberry, how many
Hmm.
A's in uh, what is stands in ChatGPT, etc. Yes, so it looks, but on the other hand, if anyone will really try to take modern code assistant like Claude and say, go and generate me this script, or I have this reconciliation idea, then most of the time it is very reliably produce something that will previously take time. So a simple example. So the one that I've mentioned is no Oracle. Uh, Go and check that in JavaScript console, there are no errors. So, and if we ask Claude Code to generate us a fixture that will go and check it, it will immediately produce it. Or if we will say, I would like to check that all my elements have test ID, it will go. So any possible idea that you can have, simple idea, it reliably produces it. So maybe there are cases, and there are cases where it generates something wrong. But from personal experience, I believe that most of the time you will ask something and it will implement idea. And previously, very often you have some ideas that I would like to check this, and that automatically, but I do not have time or to go and to write it. And now you have idea, you almost immediately have implementation of this idea. So on the other hand, if your idea is, I would like to reliably say what is on the clock, then it looks like, according to the current benchmarks, we are not there yet. So it looks like reliability is not evenly distributed.
No. And it also comes back to what we're talking about with data, right? Because if we look at what the models were probably trained on, there's probably a lot of corpus for code which you can train on. And if you're asking something that's within that problem set, it's probably pretty good at it. But is there training data for the models to determine what a clock face is in the physical world on the room? It's unlikely to be in the data set as common as maybe natural programming language code, right? That's in GitHub or somewhere else.
Yes, exactly. And this is what one has to take into account. So when one once again goes into spec-driven development, so whether it is something that the system can reliably produce based on a vast ocean of plagiarized code, or it is something that it will meet for the first time. So, but once again, so there are no solutions, there are only trade-offs. And it would be unfair to say that the instrument that we have now with code assistance, that it is useless. One can easily go and check that many ideas can be very well implemented.
Yeah. And the key thing here is having those ideas and being able to define very clearly and what you want, right? So I think, I think the roles are also changing, right? With if you can define what you want very clearly and you can write a specification as good as you can with natural language, you have a good chance of getting a good outcome compared to trying to vibe code something without really knowing what you want, without really having that specification up front. And maybe it's too large as well. So if the more smaller you are and the more direct you are and the more concise you are in what you want, you're more likely to get that, I think.
Yes, and the key word is want. To want is human. So
Sure.
to have desire, so software has no desires. Humans do have desires. And if you
Interesting. Yeah.
want something, and then most of the time it is visible. And if you want something, you can articulate that, yes, this is what I want, or you can quickly iterate from this is not what I want. There is a large group of software developers, software testers, unfortunately, who expect that there will be some external party that will tell them what they want. So you need to go and implement this, or or here is the list of
Sure.
scenarios
Yeah.
that you need to create, and it is important. So this is where the boundary between responsible tester, responsible developer, that they want something themselves. They do not need an entity that will make them want something.
Yeah, and it's ownership. I think it comes back to ownership. If you own the work you're doing, and then you know what you want to make that work meet your criteria of what you've defined, right?
Yes, exactly. Yes, and it is ownership is exactly that separates good software tester from not very good software tester. And ownership is not ownership of quality as an abstract, but ownership of for your own work, for the
Yeah.
quality of your own work. Uh, I think it is important to understand a anti-parallel structure of software development and testing. So many people who currently say that they are using uh, AI or code assistant for software testing, in reality, they are using it not for software testing, but software development. So there is a nice book called Radical Abundance. It is about nanotechnology, but the thing that stood most with me was a simple diagram that highlighted the difference between engineering and research. And engineering is when you have some idea and you turn it into a useful product. And research is where we're looking at reality and we are trying to understand it. So this the difference is the anti-parallel flow of information. So if we take idea and turn it into reality, it is engineering, it is development. If we take reality and turn it into idea, it is research or software testing. And for some reason, I'm not sure why, it is difficult to separate these two things. Of course, they work in tandem. So it is not possible to send rockets into space without solid research. But and it is also not possible to do interesting research without engineered instruments. But these are two different things, and they separate engineering and research, and they also separate software testing from software development. And let me okay, let's go from this one. So say if we are talking about generating scenarios, so we have code, and then we ask LLM assistant to produce scenarios for us. So what we do is we produce not testing, because testing is not artifacts. Testing is a process. What we do, we produce code. So essentially, we produce software. So if somebody is using LLM assistant and ask it to generate me playwright scripts. Playwright scripts are code. So what they did, they used LLM for software development. If on the other hand, they use LLM to here is something, here is a data set, or here is the output of something. Explain to me what it means. Well, it's not ideal use, but still.
Sure, yeah.
This time they are converting some reality into ideas, and it is testing. So testing is where we look at the product and get some ideas about it. Development is the other way around, and when using AI code assistants, so this is what is important. Unit tests and CI/CD are not testing; they are software.
Sure.
Because they consist of instructions. So they are core code. CI/CD is a running software. So what is CI/CD? CI/CD is some piece of software that is running and it contains if. So if something move data there, if not something, do not move data there. So CI/CD is just running code. So when we ask AI code assistant to generate CI/CD for us or make changes, what we essentially doing, we are developing software. Then there are things like, and people currently use code assistants for TDD, BDD, acceptance-driven, spec-driven development,
Yeah.
etc. What is TDD? TDD is code. BDD is also code, but in a slightly different form. We have steps specification in Gherkin, and we also have steps implementation in some other language, in Python, Java, etc. But it is code. So if we asked a code assistant to produce us Gherkin scenarios, we are doing software development. We are not doing software testing. So software testing is when we've collected some data and then we are trying to make sense of it. If something looks as if something is a bug or it is something that can be kept as is. And I think this is the main thing that one should take into account when using code assistant. So
Yeah, it's a very good point. I think that distinction of what am I doing? Am I writing code, right, to implement something, or am I doing some experimental thing, right? I'm trying to understand and learn or discover, right? Which I think are all sort of testing things where if you don't know the answer to it explicitly, then you're doing an investigation and it is basically a test to some degree. Now,
yes,
if you know the answer, you're almost writing some code, right? You may just trying to be writing an automated script or something like that that could give you the assertion you want or whatever you want. But it's ultimately code, right? It's not a testing activity. You probably know what the expectation is already.
yes, yeah, but still, it is essentially when creating TDD scripts. Well, it is expected that TDD scripts you create before you create the actual code. But what it means that instead of creating one piece of software, you create two pieces of software. Say TDD BDD is software system B, and then you create software system A. So what you do is you develop two systems simultaneously, and it is a good thing to a degree. Any model-based testing. What is if there is a model like alternative implementation? What you do? You create a model and you create the real system, and then you explore the different characteristics. So, but it is just very important to separate what is software testing
Yeah.
from what is software development, because this way you, when you think I would like to use AI for testing, you're focusing on how can I get ideas from reality rather than how can I change reality.
Yeah.
This is the main consideration.
And it's a good point because I think those words get muddled in the language we use, like we said about not being precise. I think sometimes we say we're using AI in testing, or it's not very clear what we mean by that, right? Without further definition, because does it mean if you're using AI to help you test, does it mean you're just using it to help you code and create playwright scripts or some other test automation, or are you using it to help you find oracles, right, and help you come up with a test strategy? And so, yeah, I think it's not clear, and I think it's a language problem and how we're using, like you mentioned, right? What is AI? And there's so many definitions of that just in the AI term itself.
But at least I wish everyone luck with exploring this exciting technology. I hope. I hope all of us will have a lot of fun trying to use it and trying to test systems that were vibe coded, spec driven coded, or
Mm.
just coded, or use some components that are AI based, AI enabled. So as software testers, we will have quite a lot of fun in.
I think so. I think there's going to be more work for us.
I hope so, but you never know. So there are things are changing very rapidly. People can decide that they do not need any particular process. And unless there are some catastrophic things, it is possible that before there will be more work for software testers, there will be a sharp gap before it will become clear that there is more work for software testers.
Yeah,
We'll see. We'll see.
yeah, you're probably right. There may need to be some more outages and more issues and software problems.
It is not a good thing. It's not a good thing to hope for more outages.
You may need those sort of events to get people thinking about quality and really thinking about how they build the software, that we can use specs to create code and use auto code generation. But are we still keeping the SLAs we've contractually agreed to, right? Or is the customer experience still good? I think you sometimes do need that to degrade for people to realize where the quality is, right? Why we're doing it for. Going back to your first point, right? When you create a bug, who is the user of that bug? Who's it affecting? So sometimes you need to affect those people for it to really get understood the value that testing brings. Great. Thank you so much for coming on. I really appreciate it. I've learned a lot going through your content, and I'm sure other people will. So if people want to reach out to you or find out more about you, where should they go?
I'm available in LinkedIn as Iosif Itkin. There, it is easy to find. And
Great.
thank you very much for the invitation. It was truly, truly a pleasure. I like to talk about software testing. Thank you.
Me too.
Thank you very much.
Thank you, Iosif. Appreciate it. Thanks for coming on.